Hello, and welcome back to our channel. And I hope each and every one of you is doing great. Yes, I hope you're doing well. I'm happy to be back again so we can continue with our tutoring journey. Today, we're still looking at mathematics, and we're going to be looking at a topic known as number bases. It's going to be all comprehensive so that it will be your go-to get to video on number bases, so that no matter what you need on number basis that is going to be addressed for your needs. All right. Without wasting much time, I want us to zoom right in. All right, we're going to zoom right in. So we are going to look at number basis. We're going to look at number basis, and I want us to go through the topics, the content of the video. We're going to look at the content of today's video. We're going to look at number bases. Yes, we're looking at number bases. The topic for discussion. We're looking at number bases, but we're going to be looking at the content of this video. The content we have. The first thing we're going to have there is that we're going to look at some introduction, a quick introduction on what number base is all about, an introduction concerning number bases. The second thing we'll be looking at is how to be able to do addition, how to do addition, and subtraction, addition and subtraction of number bases, and we'll be working out some kind of examples to go with that. All right, we'll be looking at some examples as well, and then we'll be looking at multiplication. As usual, we can't work things on addition and subtraction and ignoring multiplication. So we want to look at how we multiply number bases, how multiplication is conducted in number basis. And then the next thing we're going to be looking at, the next thing as after multiplication, is how we can be able to convert a given base to base 10, a given base, maybe base 2, something is in base 3 or 4 or whatever, a given base into base 10, how we can be able to do that, how we convert that to base 10. And then the next thing, converting a given base into base 10 is to be able to convert from base 10 to other bases. So from base 10, let's say from base 10 into other bases, into other bases. So we have base 10, something is already in base 10, and we want to see how that translates to be base 2, base 3, and all that. All right. The next thing we can be looking at, the next part of the content of this video, is also to look at how we can be able to convert between different bases. So let's say from base 2 to base 4, all right, from base 3 to base 7 or whatever. So we're going to look at how we can be able to convert from one base, all right, to another base. So this time around, it's not going to be from base 10 to something, or from something to base 10, but it's going to be between base 2 to base 4, base 5 to base 6, like in that order. All right, in that order. And then I think we're going to conclude the content of the video concerning unknown base. Let's say we are given something and the base is unknown. We are having a base, but we don't know what we're having a question, but there's no base in there. How are we able to determine? How are we going to determine the base in which that particular thing is in? So we're going to look at unknown base. Unknown days. I hope this is getting excited for you, and you're already getting excited. If you're already getting excited, I think we are, the feeling is mutual. So let's start. Let's start with the introduction. We're going to be looking at number bases, but we're looking at the introduction of number. Sorry about that. Introduction of number bases. We are going to look at the introduction. We're going to look at the introduction of number bases. So we're looking at introduction of number bases, and we all number system in our daily activities is done in base 10. Everything we do, remember when we're solving problems in grade 2, grade 3, we're normally given something like 2, 3, 4, and we are being told to add it to maybe 1 to 7. You remember something like this? We add 7 to 4, and it gives us 11. We write a 1, remainder 1, we put it here. We add that 1 to the 3, we get 4. We add that 4 to 2, we get 6, and we add 2 2 plus 1, we get 3. So all this that we are doing is in base 10. So technically, it should have been written in this way. Let's say 2, 3, 4 base 10, right? Plus 1, 2, 7 base 10, all right? So that's the everyday working that we normally deal with. So all number bases, all number system in our daily activities is done in base 10. If I talk about $20, then it's in base 10, because I don't say $20 base 2. So every number that we deal with in our everyday is in base 10, also called the denary or the decimal numeral, also known as the denary or decimal numeral. So we are saying that each and every day, each and every day, we deal with number bases. That is in what? That is in base 10. We always deal with something that is in base 10, and that is known as, we are saying that it is known as the denary or the decimal numeral. The um the decimal numeral the decimal numeral. All right, so that's always is always in base 10. It's always in base 10. So base 2 is known as binary because it has 2 digits. All right, it has 2 digits. So if we talk about anything in base 2, let's say we are dealing with base 2, then it's known as binary. We are dealing with what? Binary. Bi means 2. This one here means 2. It means 2. Binary means 2. So if we're dealing with anything that is binary, that's base 2, it means it has 2 digits. It has 2 digits. So it has 2 digits. 2 digits, and one is 0, then the other is also 1. So this is binary. It's a binary digit. Is binary digits. All right, is binary digits 0 and 1. Now if you look at a base 3, anything if we want to talk about base 3, all right, then we are looking at 3 digits. We're looking at 3 digits. We're looking at three digits, and that is going to be what? It's going to be 0, it's going to be 1, and it's going to be 2. So if you look at base 3, it ends at 2. If you look at base, let's say 9, if it's base 9, then it's going to end at 8. It's going to be 0, 1, 2, 3, all the way to 8, like that, in that order. All right. So that's something I want us to we want to keep in mind. We want to keep in mind with that. All right. We want to keep in mind with that. Now, if we also look at base, let's say we're talking about base 11. All right. If we say base 11, something is in base 11, it has 11 digits. All right. It has 11 digits. All right. It has 11 digits. And if it has 11 digits, it means it's going to be from 0, 1, 2, 3, all the way, all right, all the way to 10. 10. But we're going to use T for that. We're going to use T to represent that, the 10, okay? And then if we are working in base, let's say we're working in base 12, then it's going to also have 12 digits, 12 digits from 0, 1, 2, 3, all the way to what? 10 and 11, right? 10 to 11. So we are going to have T here, and then we're also going to have 11, and we're going to use the E to represent the 11 base, all right? T and E are here, it stands for 10 and 11 respectively when dealing with base 10, base 11 and 12. All right, so if we're dealing with base 11, it ends here. We're dealing with base 12, it ends at 11, like that, in that particular order. From the above illustrations, for what we have seen so far, when we are given a base, we're always less than the base itself. So if you have base 3, it will end at 2. If you have base 10, it ends at 9, in that order. So let's look at an example. Let's say that we want to count. We are counting. Let's imagine we are counting in base 6. We want to count in base 6, for example. All right, we want to do this. We know that it has to end at what? 5, technically, right? So we're going to count from 0. We're going to count 1, we're going to count 2, we're going to count 3, we're going to count 4, we're going to count 5. So it's supposed to actually end here, right? That's where it's supposed to end, right? But if we decide that we're going to bring, let's say, 6 in here, but we want to still work it in base 6, This 6, how do we write this 6 in base 6? Because we know base 6 should end at 5. But now we still want to go overboard the 5 and decide how are we going to rewrite that 6 in the base. How do we do that kind of writing? So this 6 will be that, how do we say 6? This base, this is the base, right? We are in base, we want to work in base 6, and this number is 6. Base 6 is supposed to end at 5. But since we've gone overboard the 5, we want to still write base 6, this 6 in base 6. We'll say that we'll ask a question. 6 goes into this 6. This number 6 goes into base 6. How many times? It will go inside 1, and then there'll be a remainder. There'll be a remainder. It will be 1, and then it will be what? Remainder what? It will be remainder 0, right? It will be remainder 0. If it is 7, right? 1 remainder 0. But if it is 7, okay? If it is 7, let's say we go to the next number. The next number is 7. It will be 6 goes into 6 goes into, right? The base goes into the number 7. The base itself, this base, goes into 7 how many times? And that's going to be 1, but remainder 1. 1 remainder 1, which is like 11, kind of. And this 1 remainder 0 is like 10, technically. And then we keep doing that, etc., etc., etc. If we take the number, let's say 13, the next number is, let's say, 13. We're gonna ask that base 6 goes into the number 13 how many times? All right, it's going to be 1. It's going to be 2. Remainder 1. Do you know why? Because base 6 will go into 2. That gives us 12, and there's still going to be a remainder of 1. There's going to be a remainder of 1, which is basically 21, or what, writing in that particular sequence. All right. So the same approach can be used to count in other bases. So if we look at, let's say that we are looking at specifically base 7, right? We want to work in base 7, and we know that to work in base 7 is going to be from 0, 1, 2, 3, 4, 5, 6. That's where it's supposed to end. But imagine we go into the next number is 7. Then we're going to ask base 7 goes into the number 7 how many times? It's basically 1. It's going to be 1, but remainder 0. It goes inside 1 exactly and remainder 0. If we take the next number, and the next number is 8, we're going to ask the question that base 7 goes into the number 8 how many times? It's going to be 1. It's going to be 1, remainder 1. 1 remainder 1. Why? Because 7 going into this 8 is going to be 1. So that 1 times 7 is 7, but there's going to be a remainder of 1. So it's 1 remainder 1. And we're going to apply this for any other base. We're going to apply that for any other base. All right. If you're great, let's move on to the next content. The next content is going to be addition. We're going to be looking at addition. We're going to look at addition and at the same time subtraction of number bases. Okay, of number bases. All right, addition, subtraction of number bases. That's what we're going to be looking at. All right, that's what we're going to be looking at. So let's zoom. Let's zoom straight right in. We're going to zoom in, and everything is going to be beautiful. Everything is going to be beautiful. Now we're going to look at this addition and subtraction of numerals. Addition and subtraction of numerals. If we're trying to do, addition and subtraction, from which are different, which are not the same as the base 10 that we know, the decimal numeral. It's the same thing, it's the same how we do it. Like, for example, we're looking at, let's say, let's take a look at this, for example. Let's say that we have, I want to make it practical so that I can reserve a little bit of talking. So let's say that we have 3, 1, 1, and it's in base 4. And can you see that it's in base 4? Because there's no digit in here which is greater than 4. Can you see that this 3 here is less than 4? This 1 here is less than 4. This 1 also is also less than 4. If anything's in base 5, it's going to be less than 4. The number should end at 4. If it's in base 6, the number should end at 5, in that order. So we've been given a problem here, and the problem we have is 3, 1, 1. And that 3, 1, 1 that we are having, all right, That 311 that we are having is in what? Is in base 4. That 311 that we are having is in base 4. All right, it's in base 4. So we're gonna have base 4 here, and then we are adding it to 213. We are adding it to 213. We are adding it to 213. And then that 213 is also in base 4. Let's imagine that it's in base 4. You can see this is less than 4, and then this is also less than 4. So that's the confirmation that we are working in a number that is less than that's less than 4, and we're working in base 4. And we want to do an addition. We want to see how that works. All right. So let's zoom right in. Now we're going to always start. Remember when we're doing our addition, our usual addition, we always start from the right. All right. So 3 added to this one is 4. Can you see that? It's 4. But we are working in base 4. We can't write the number 4 here. We can't write 4 here. We can't do that. Because when we do that, we are violating something here. We can't do that. So we need to change it. We want to change it. So the question we're going to ask, we had 4, right? We had 4. We're going to say that base 4 into 4. What are we going to get? It's going to be exactly 1. Base 4 can go into base 4, 1. Exactly 1. And then there's no remainder. The remainder is 0. The remainder is 0. So technically, we're supposed to write it as such 1, 0, right? But the number on the right is what we always write. Do you remember, for example, when we're working in, let's say, 2, 7, 4, and I'm adding it to 1, 6, let's say 9, and it's in base 10, base 10. Remember, we do normally work our base 10, and we say that 4 plus this 9 is 13, right? It's 13. And then you see, we write this number first. We always write this 3, and we carry this one. We bring this one here, right? You remember that? Because this 13, we are saying that base 10, we are working in base 10. Base 10 into the number 13 that we added will give us 1. It will go into it 1, but there'll be a remainder of 3. It's the remainder that we write. We write a remainder, and we carry this one over. So that's the same thing that we are doing here. We're doing the same thing here. We had 4, and we asked the question, can base 4 go into base 4 into the number 4 is exactly 1 remainder 0. And remember, we always write a remainder first. So here it's going to be 0, and we carry out the 1. This 1 will go over there. And then 1 will add to this 1. It will be 2, and that 2 plus this 1 is going to be 3. And we have it here to be 3. Now remember, this 3 and 2 is 5. So we're going to ask the question, base 4 into the number 5 that we've added. The base 4 into the number 4 can go into 5 one time, because 1 times 4 is 4. And there's going to be a remainder of 1 to give us a 5. Remainder of 1. So what do we write first? We write the remainder first, which is going to be 1 here, and then the other one is also going to be on the other side. And then our answer is still in base 4. You can tell that these numbers are less than 4. They are, each of them is less than 4. All right. Let's take another example. Let's take another example, and the question is, if you have 1, 1, 0, 1, 0, and what do you think this should be in base? It should be in base 2, because the highest number in this thing is 1, so it's in base 2, and then we are adding it to, okay, we are adding it to 1 here, a 0 here, a 1 and a 1 there, and then it's also in base 2. It's also in base 2. They're in the same base, so we don't have any problem. So the first thing is always start on the right side. Always we start on the right side here. This 1 plus this 0 is 1, and this 1 is in base 2, right? It's not bigger than the number 2, so we are fine. But if we take this 1 and multiply and add to this 1, we get 2. So because it's 2, we cannot write 2 here. We can't do that. So what do we do? Because we can't write 2, we are working in base 2, so we can't write 2 there. We're going to ask the question, base 2 into the number that we just added, which is 2. It's going to be 1 remainder 0. And remember, we always write the 0 first, the remainder. So that means that here is going to be the remainder, which is 0. And then a carry here, you're going to put a 1 here. This 1 is going on top here. Now we're going to add this 1 to this 0. And then to this 0 and add it to this 0, and we basically get 1. When we can write 1 because 1 is less than the base 2. Okay, now the next thing is adding 1 to this 1, and we get 2. Same thing. When we did that, base 2 into 2 is 1, remainder 0, right? And we said we always write the 0 first. So we wrote a 0, and then this 1 here, we add it here. We'll come up here. And then we add that 1 to the 1, and we end up getting 2 again. And then 2, having 2 is the same as 1 remainder 0. So the 0 is always written first, the remainder is written first, and then we put a 1 here. And basically, our answer becomes 100, 101, and then base 2, and then base 2, and then base 2. Is that okay? Is that okay? Now let's quickly look at some other few examples. All right, we'll look at some few examples. Let's imagine that we have 224, 5 written this way, plus 214, also 5 written this way. We can rewrite this. We can rewrite this as 224 base 5. And you can see that the numbers in there are less than 5. We can also add 214 to it. And it's also in what? Base 5. We are adding it. We are adding it. And when we do that, you can see that this 4 plus this 4 is 8. Now base, what base are you working in? We are working in base 5. Base 5 into 8. Base 5 into 8 is what? 1. 1 times 5 is 5. Remainder is 1. Remainder what? Is 1. Remainder 3. Is 1. Remainder 3. Is 1. Remainder 3. So what do we write first? We always write this 3 first. We write this 3 first. We're here. And then this 1 goes on top here. Now we're going to have 1 plus the 2. 1 plus the 2 is going to be 3. Plus this 1 is 4. And we can write it. 4 is less than base 5. So 4 is going to be here. And then this 2 plus this 2 is going to give us what? 4. And then that 4 also, we write it here. And all that is still in base what? Base 5. And then we are good. We are good. We are good. Let's take another example. I'm going to do another example on this side right here. Imagine we have 757 and it's in base 8. And we are adding it to 565. It's also in base 8. Can you see that? When we are adding, we can do that because all the numbers here are less than 8. So we can do that, right? We are adding this 5 plus this 7 is 12. So we say base 8 into 12. What do we get? It's going to be 1 remainder 4. 1 remainder 4. So we write the remainder first, which is 4 here. And then this 1, we'll put it here. And we add the 1 to the 5, we get 6. The 6 plus the 6, we get 12 again. And it's always 1 remainder 4, right? So we write a 4 again. And then this 1 will come up here. So that 1 plus the 7 is 8. 8 plus the 5 is 13. Now that 13, we can ask the question, base 8 into 13, right? Base 8 to 13 is also still 1 remainder 5. 1 remainder 5. And remember, we write a 5 first. Don't forget that. We always write a 5 first. So it's going to be 5, and then we bring the 1 on the side here. So that we're going to have 1544 base number 8. I think we've done a couple of examples. We've done a couple of examples on addition. Let's try our hands on some subtraction and see. Let's get our feet wet with some subtraction. But I think the same rules apply to what we did in addition. So I think we shouldn't have too much of a problem doing that. Now imagine we have 523 base 7. All right. And then we are having minus 65 base 7 again. All right. Let's imagine that for a second. All right. So 523 minus 65, all of them in base 7. Each and every one of them is in base 7. What do we do? Remember, we always, when we're working out subtraction, we take this number and we take it out from this number. But we cannot, it's not possible to take 5 from 3. Can you see that? 5 is bigger than 3. So we can't subtract 5 from 3. We can't do that. We can't do that. We cannot do that. Okay, so we are going to decompose. We're going to decompose 1. We're going to borrow. I call it borrow. We're going to borrow 1 from here. We're going to borrow 1 from this 2 and bring it here. That 1 we are bringing here, that we are borrowing, is actually what? That 1 that we are borrowing is going to be what? It's going to be 2, right? Okay. It's going to be 2. All right. We decompose 1 from the 2. From the 1 which is from the 2, and that is 7. So we are working in base 7. Sorry about that. So the 1 that we are borrowing here is actually 7. But remember, we've taken 1 from the 2, so that was going to be 1 here. When we take 1 from the 2, it's actually 1, no more 2. But that 1 that we are bringing here is going to be 7. Okay, and we add that 7 to the 3. We add that 7 to the 3 and we get 10. So basically here becomes 10. Can I take it that again for you? Maybe things are not getting clearer for you. So let me probably do that. Let me work. Let me repeat what I just said. I want to repeat it again. Maybe it might serve us in a better purpose. Now remember, we are working in base 7. We are working in base 7, all right? We're working in base 7. And we are saying that we cannot take this 5 from this 3. It's not possible. So we come to the next neighbor, which is 2. And we take 1 here. The moment we borrow 1, the moment we are borrowing 1 here, we're borrowing 1 here. That 1 that we are borrowing becomes 7. And then here becomes 1. Why? Because we've taken 1 from the 2. So the 2 is no longer 2 there. We took 1 out of it and it's now 1. And that 1 becomes 7. That's 7. We're going to add it to the 3. We're going to add it and we get 10. Once we get 10, we take the 5 that we are having here. We take it out from this 10 and then we are going to get 5. Now we've written 5 because 5 is less than 7, so we are good. But remember, we are left with 1 here. We cannot take 6 from this one either. We can't take 6 from this one. So we come back here again, take 1, and that 1 is 7. When we add it to the 1 that was already there, it becomes 8. Then we take 6 from the 8, we get 2 here. But remember, we took 1 from the 5, so it's no longer 5. It's becoming what? 4. We know the one we took is 7, but we can't say we took 7 out of 5. It's just one we took. But when we bring it to the place that where we need it is that base. So now if this is 4, yes, nothing. You can see yes, nothing. So nothing from the 4 gives us 4, which is 4, 2, 5, and it's also in base. It's also in base 7. Now let's try another one here. Let's imagine that we have 1, 1, 0, 1, 1, and it's in base 2. And we're subtracting 1, 0, 1, 0, 1, also in base 2. Okay, let's say we are going to do something like this. We said we're always going to start from here. We are working in base 2. 1 from 1. If we take 1 from 1, it's possible. We get 0. We can write 0 because 0 is less than base 2. So we're good. But what about taking 0 from 1? Is it possible? Yes, it is possible. We can take nothing from something, which is that something, which is 1. And that 1, 2 is less than 2. So it's possible. But what about taking 1 from nothing? You can't take 1 from nothing. There's nothing in there to take. So what are we going to do? We're going to take 1. We're going to decompose. We take 1 here. And that 1 that we are taking is 2 because we are working in base 2. It's 2. That 1 that we are borrowing is 2. And then once we borrow 1 from that 1, here becomes 0. It's no longer 1. It's 0. Now this 2, we add this 2 to the 0 here. We get 2. And we take 1 from that 2. And then we get 1. Now remember, here is 0. And here is also nothing. So here is going to be 0. And then we have 1. Nothing from 1 is 1. And then our answer is still going to give us in base. It's still going to leave us in base 2. It's still going to leave us in base 2. All right. Now, there's a problem here that I want us to share together. Let's imagine that we've been given 141 base 6 plus 233 B6 minus 145 B6. Do you remember PEMDAS? I don't know whether you remember PEMDAS or board mass. PEMDAS or board mass. You can see that we have to solve the problem in order of operation. Now we have 2 operation signs. This one, addition and subtraction. Which one do we solve first? You can see either the board mass or the PEMDAS. We start with the addition first before the subtraction. So we're going to start down 1 first. So we're going to rewrite this, and we are going to have 141. We're going to have 141 base 6. We're going to add it to 233 base 6. We're going to do this like that. All right. Now this 3 here that we are having here, this 3 here, we're going to add it to this one. We're going to get what? 4. When we add, we get 4. We have our 4 here. Now this 3 here, we add it to the 4, we get 7. Now remember, 7 is now bigger than this base. So we're going to ask the question, the base 6 goes into the number that we added, which is 7. How many times? 6 will go into 7 one time, and the remainder is going to be what? 1. We will always write the remainder first. So 1 is going to be here, and then this remainder 1 will come here. We add the 1 to this one is 2. 2 plus 2 is 4. And we're having 414 base 6. Okay, now we are not done because we've only done this part. Now we are left to doing the subtraction together with it. So it's going to be 414 base 6 minus 414 base 6 minus 145 base 6 minus 145 base 6. Now we're going to start with this 5. Can we take 5 from 4? Can you answer the question, please? We cannot. We cannot take 5 from 4. We cannot do that. It's not possible. So we can go to the next neighbor, which is 1. 1 is here. We take 1 from here, and the one that is going to come here is the base. Which base are we working in? It's 6. So it's going to be 6 here. We add it and we get 10. Can you see that? We add it to the 4, we get 10. Then we take the 5 from this 10 and we get 5. But remember, when we took 1 from this one, that 1 is no longer 1, it's now 0. Can you take 4 from this 0? No, it's not possible. But we can come to the next neighbor and bring 1 here. That 1 that we're bringing is which base? It's base 6. So we add the 6 to this 0. It gives us 6. 6 plus 0 is 6. Now we can take 4 from that 6 and we get 2. But remember, we took 1 here. Once we took that 1 here, this 4 is no longer 4. It's now 3. 1 from the 3 is 2. And we have 225 base 6. 225 base 6 as our final answer. As our final answer. All right. We can also be given a problem where we are being asked to construct an addition table. Okay, they can ask us to construct an addition table or a subtraction table. All right, so we can be given that construct a base 7 addition table. Let's say we have a set. We are given a set, and then the set is made up of these numbers 1, 3, 5, and 6. Can anyone tell me what these numbers can be? Which base they can be in? Can you pause the video and be able to answer the question for me, please? This is in base. It's in base 1. It's in base 7. Why? Because the last highest number, the highest number in this set, is 6. So if it is the highest of 6, then we are working in base 7. That's what it means. So if we are having base 7, we are going to construct a base 7 addition table. We are going to construct a base 7 addition table. So because that is a set, we're going to have on this side, this is a plus sign. But on this side, we're going to have 1, 3. We're going to have 1, 3, 5, 6. The members in the set, and on the top part, the same numbers. We're going to have 1, 3, 5, and 6. They asked us to construct an addition table, and we've done that. So now we're going to be adding 1 and 1. We add 1 in this one. It's actually 2. Can we write a 2? Yes, we can. Can you see that? We can write that 2 because it's less than 7. 1 in this 3 is what? It's 4. We can. It's less than 7. 1 in this 5 is 6. We can. 1 in this 6 is what? It's 7. Can we write 7 in base 7? No, we can. But we need to ask the question. Base 7 into the number 7 that we added, the 1 and the 6. What do we get? We get 1, but it's going to be remainder. It's 1 remainder what? Remainder 0. 1 remainder what? 0. So we said that we always write a remainder first, and then the thing we are carrying like that. And then we go to the next one. 3 and 1 is 4. 3 and 3 is 6. Can we write 6 in base 6? In base 7? Yes, we can. In base 7, we can. So we are working in base 7. We can write 6. 3 and this 5 is 8. We can't write 8 here. No, you can't do that. We have to convert that. We need to change it. And to do that, base 7 into the number we added, which is 3 and 5, which is 8. It's going to be 1. It's going to be 1 remainder 1. It's going to be 1 remainder 1. It's going to be 1 remainder 1. So we always write the remainder and write the other number again, like that. So technically 11, but it's not 11, it's 1 remainder 1. Now 3 and 6, if you add 3 and 6, you're going to get 9. So it's going to be base 7 into 9. Base 7 into 9 is going to be 1 remainder 2. 1 remainder 2. 1 remainder 2. So we write the remainder 2 first, and then we put a 1 here. The next one is 5. 5 and 1 is 6. We put a 6 here because we can write 6 in base 7. What about 5 and 3? 5 and 3 is 8. 8 is what we did here. Base 7 into 8 was 1 remainder 1. So 1 remainder 1 and then the 1. 5 and 5 is 10. So base 7 into 10 is going to be 1 remainder 3. So we write the 3 first and then 1 later. 5 and 6 is 11. 7 into 11 is 1 remainder 4. So we write the remainder, which is 4 first, and then we add the 1 here. Now 6 and 1 is 7. We can't write. We cannot write 7 because we are working in base 7. And that is 0, the remainder, and then 1 on this side. 6 and 3 is 9. 6 and 3 is 9, and that's remainder 2, and then 1 on this side. 6 and 5 is 11. And 11 is going to be 1 remainder 4, which is 4 and then 1. And then 6 plus 6 is 12. 7 into 12 is going to be 1 remainder 5. So we write a 5 and we put a 1 here like this, and then we're good. And then we're good. Now that we've constructed the addition table, we can be able to, we can be asked, okay? So we can be asked, are you there with me? Please hang in there. We can be told to find certain number bases together. So let's say that we've been given 3 plus x, 3 plus x, okay? 3 plus x is equal to 12 base 7. 12 plus base 7. So they're asking us that if we take 3 here and you add it to something we don't know, we're going to get 12 base 7. And 12 base 7 is either this one or that one. Can you see that? Because the 3 added, right? It says 3 added to something gives you 12 base 7. The 12 base 7 is these, only these two numbers in addition table. Can you see that? But the question says 3 plus something. So this is the 3, this one here, this line here, is where we find the 3 plus the something. But over here is 6. So this is cannot be, it cannot be that, because 6 is not what we are looking for. We are saying that 3 plus something. All right, 3 plus something will give you 12 base 7, right? 3 plus something will give you 12 base 7, right? Will give you 12 base 7. And it's 3 plus what? It's 3 plus 6. Can you see that? It's 3 first. It's 3 plus 6, giving us the 12 base 7. You can see that 3 plus the 6 gives us the 1, 2 base 7. The 1, 2 base, base 7. I hope this clarifies so many things. Now let's move straight right in and go into multiplication. Let's go to multiplication. We look at multiplication of sets. So we look at multiplication of number bases. So multiplication of number bases. Multiplication of number bases. Multiplication of number bases. Multiplication of other bases is the same as that of ordinary multiplication. All right, we're going to do all that we've learned is the same thing. You remember when we used to do, maybe you are given 24 multiplied by, let's say, 5. We multiply this 5 by this 4. It's 20, right? 20, we write a 0 first, remember that too. And then 5 multiplied by this 2 is 10. And we add this 2 to it and we get 12. It's the same principle. Now remember, 5 multiplied by 4 is 20, right? But we are working in base 10. Base 10, so it's 10 into 20 is what? Is 2, can you see that? Remainder 0. That's why we write the remainder 0 and then we carry the 2. So it's the same concept. We're going to be applying the same concept here. All right. So all that we've been doing in school, previously before coming to meet number bases, is actually, it means that we're working in base 10. All right. So we're going to see how we can do multiplication for other types of bases. Okay. So let's imagine, we're going to imagine for a second that we have this. We've been given to evaluate 1 base 2 plus 1 base 2, and it's all multiplying 1 base 2 minus 1 base 2. Can you see that? Now this parenthesis coming together means it's multiplication. We're going to be doing multiplication pretty much. But before we do the multiplication, remember PEMDAS and BODMAS. PEMDAS and what? Board mass. And here's parentheses. This one is parentheses and this bracket. They're the same. So we have to start that one first. All right. And to do that, can we just pick any one? We can. But I think it will be better. It will be better if we start with the one with addition before the subtract. The parentheses that has the addition first. So let's start from there. All right. So we're gonna have 1 base 2 being added to 1 base 2. We're working this side first. Now, 1 plus 1 is 2. Can we write 2 here? No, we can't do that because we are working in base 2 and we need to work in base 2. The last number there should be 1. The highest number should be 1. So 2 into 2 will be what? 2 into 2. Base 2 into 2 is 1 remainder 0. So we have 0 and then our 1 here. 1 plus 1 is 2 again. 2 into 2 is 1 remainder 0. So it's going to be 0 remainder 1. 1 plus 1 plus 1. 1 plus 1 plus 1 plus 1 is 3. So we're having base 2 into 3 is 1 remainder 1. So we're going to have 1, 1 like that, and all in base 2. So we're having 1, 1, 0, 0, base 2. Multiplying. Why multiplying? Because of these parentheses together. And then we're going to have we are going to have, um, let me take off this side a little bit. Okay, please bear with me. So remember that we also have one, this side is having 1 1 1 base 2, 1 0 1 base 2. We are doing subtraction. Can we take 1 from this one? Yes, we can. We get 0. All right. Can we take 0 from 1? Yes, we can take 0 from nothing. Is that something? 0 from something, is that something, which is 1. And 1 from 1 is 0, like this, and all in base 2. So basically 10, 1 0 base 2, technically. 1 0 base 2. So we're going to have our 1 0 base 2, and we're going to do our multiplication. We're going to do our multiplication, which is going to be 1 1 0 0 base 2 multiplied by 1 0 base 2, like that. What are the rules? We always start with which one? We always start with this. This 0 multiplied by this 0 is 0. This 0 multiplied by this 0 is 0. This 0 multiplied by 1 is 0. This 0 multiplied by this 1 is 0. All right. Then we go to the next number. 1 1. You see where the 1 is under here. So 1 multiplied by 0 is 0. So we write it under, there's 1 there. 0. The 1 multiplied by 0, 1 multiplied by 0 is also another 0. We bring it here. But 1 multiplied by 1 is 1. And we bring the 1 here. 1 multiplied by 1 again, the last one, is also 1. And the next thing is to do some form of addition. Okay. Some form of addition. So this 0 added to this one. So let me do it this way. This 0 added to this 0 here. Where are we? So let me rewrite it again. Imagine we have the 4 zeros here. 1 2 3 4, and then we are having another 0 here, another 0 here. All right, 0 0 1. All right, 0 0 1 1, like this, and we are adding everything so we can get our answer. What we're going to do is that this 0 added to 0 is 0. This 0 added to this 0 is 0. This 0 added to 0. This 0 added to 1 is 1. And then this 1 added to 1 is also 1. So we end up getting 1 1 0 0 0, like that. 1 1 0 0 0, all in base 2. All in base 2. All right, I'm going to take one more example on multiplication. And then remember, once we do that, we'll take a look at constructing a table, a multiplication table, and how that one also works differently from what we did for the addition table. Let's see what that is going to be fun. All right. Now let's look at a situation where we have 2 1, 2 2, and it's base 3. It's base 3. It makes sense. And we're multiplying by 2 1 2, and it's also base 3. We're multiplying by that. All right. We're multiplying by that. Okay. So always start from here, the right. 2 times 2 is 4, but we cannot write 4 because we're working in base 3. So it's going to be 3 into 4. It's going to give us 1 remainder 1. So we write 1, and then the remainder will be here, like this. So that this 2 multiply this 2, 4. We add a 1, we get 5. So 3 into 5 is 1 remainder 2. So we're going to write 2 remainder 1. We put that 1 here again. So that 2 times the 1 is 2. All right, 2 times the 1 is 2, plus the 1 is 3. We cannot write 3 because it's 3 into 3 is 1 remainder 0. So we write 0, and there's also another remainder of 1. So that 2 times this 2 is 4, plus that 1 is 5. And then we're going to have 3 into 5 is 1 remainder 2. So we're going to have 2 and 1 on this side. So so far we have 1 2 0 2 1. Like that. We are not done. We're already only done with this side. Now we're coming over here. 1 times 2. 1 times 2 is going to be 2. 1 times this 2 again is going to be 2. 1 times this 1 is going to give us 1. 1 times this 2 is going to give us 2. Like that. All right. That means we are also done with this one here. Now let's look at the third one. All right. The third one is this one. So 2 multiplied by this 2 is 4. And we said that 3 into 4 is 1 remainder 1. Can you see that? We write it under this 2. So it's going to be 1 remainder 1. We put that remainder where? Because we started from this times this 4. So that remainder should go here. All right. This times this was 4. And that 4, 3 into 4 was 1 remainder 1. So we've written the 1 under this 2. And the other carry will be here. So that 2 times this 2 is 4. 4 plus that 1, 4 plus that 1 is 5. All right. How do we write 3 into 5 is 1 remainder 2. So we're going to write 2 here and then another remainder. The other remainder will be here. All right. So that we're going to have, because we already did 2 times this, 2 times that, and now we are here. 2 times 2 is what we did. 2 times this, we already done. Now 2 times 1, okay. Don't forget we have a remainder 1, right? Which line are we? We're here. Remember, we did this first. We started with this 2 here. We multiplied by that, we had 4. We converted the 4, we had 1 remainder 1. All right, and we put it on the next one. We did that. Then we came here by using this one to also multiply all of them. Now we are over here on the last one. We did 2 times 2 is 4, is 1 remainder 1. We put it here. 2 times 2 is 4. We added a 1, which is 5. 5, which is 2 remainder 1. That 1 is here. Now we're going to have 2 times 1 is 2 plus that 1 is 3. 3 into 3 is 1 remainder 0. So 0 remainder 1. And then that same 2 is going to multiply this 2. We get 4. We add 1 is 5. And 3 into 5 is 2 remainder 1. Is 2. Is 2 remainder 1. And we're going to add everything. So this, if you add everything, we're going to 1 with everything is 1. And then 2 plus 2 is 4. Is 4. And 4 is this one here. Is 1 remainder 1. So 4 is 1 remainder. So we're going to have 1 remainder 1 here. 1 remainder 1. 1 remainder 1 here. Okay. And we're going to have 1 plus 2 is 3 plus that 1 is 4. We still have 1 remainder 1. All right. So that 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 1 is what? 6. So that 3 into 6 is 1. So it's 2 remainder 0. So we're going to have 2 here. Now we're going to have the 0. Remember we said that we always write the remainder first. So 0 remainder 2. Like that. 0 remainder 2. So that 2 and 1 is 3. 3 plus 2 is 5. And we can be able to write 5. We cannot be able to write 5 because we are working in base 3. So it's going to be 3 into 5 is 1 remainder 2. We write the 2 first, the remainder first, then the carry. The carry is going to be 1 here. So 1 plus 2 is 3. 3 into 3 is 1 remainder 0. It's 1 remainder 0. So you have 0 and then 1 here. And then that 1 plus 1 is 2. So we're going to have 2, 0, 2, 0, 1, 1, base 3. All right. So that's multiplication. That's multiplication for you. Now let's take a quick look at if you are constructing a multiplication table, just like we did for the number basis for another operation sign, which was addition. All right, which was addition. So let's imagine we are constructing. We've been told to construct a base 6 multiplication table. Now, because you're working in base 6, the numbers will always start from 0. Don't forget, they're always going to start from 0 to 5. So 1, 2, 3, 1, 2, 0, 1. Sorry about that. It's going to be 0, 1, 2, 3, 4, and 5. Why does it end at 5? Because we are working in base 6. And in the same way, we are going to have on the top here, we're going to have 0, 1, 2, 3, 4, and 5 also here. But remember, the multiplication sign is what we are dealing with here. The multiplication sign, right? We are trying to multiply all of them together. So if we multiply 0 and 0, we get 0. 0 and all this is going to be 0, right? We are multiplying by 0, we get 0. Now 1 and 0 is also going to be 0, but 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 5 is 5. 2 times 0 is 0. 2 times 1 is 2. All right? 2 times 2 is 4. 2 times 2 is 4. But we are working in base 6, so we can write the 4. All right? 2 times 3 is 6. We cannot write it in base 6 because we know that 6 into 6 is 1 remainder 0. So it's going to be 0 and 1. And then 2 times 4 is 8. 6 into 8 is 1 remainder 2. So it's going to be the remainder first, and then the 1 on the side here. 2 times 5, this 1 times 5 is 10. 6 into 10 is 1 remainder 4. It's 1 remainder 4, which is 4 here, and then a 1 there, in that order. All right. Then 3, we multiply the 0, and then that gives us 0. 3 multiplied this 1 is 3. 3 multiplied the 2 is 6. 3 multiplied the 2 is 6. And we know that we're working in base 6, so it's going to be 6 into 6 is 1 remainder 0. It's 1 remainder 0. So we're going to have 0, and we're going to have 1. 3 times 3, this one here, multiply by, it's 9. It's 9. It's 9. So we're going to ask the question, 6 into 9 is 1 remainder 3. It's 1 remainder 3. So we're going to add 3 here, put a 1 here. 3 multiplied by 4 is 12. 3 multiplied by 4 is 12. And 12 will be 6 into 12 is 2 remainder 0. All right? It's 2 remainder 0. So we're going to have 0 and 2 in that order. We're going to have 3 times 5. This 1 times 5 is 15. Yes, it's 15. And 6 into 15. Yeah, 6 into 15 is going to be 2 remainder 2. All right, 2 remainder 2. Where do we write that? We can rewrite that here, 2 remainder 2. Like that. All right, can you be able to pause the video and continue this filling in the blank here? Can you be able to do that? Yeah, please do so. All right, please do so. All right, so that we can go to the next content of the video. All right, the next one. Content of the video. Remember, we said that we're going to learn how to convert a base, all right? How to convert a base into what? Base 10. Okay? You're going to look at how to convert a base to base 10. All right? How to convert a base to base 10. We can be able to look at that. How to convert a base to base 10. How to convert a base to base 10. Now let's imagine that we have 1, 1, 1, 0, 1, and it's in base 2. And we are being told to convert it into a base 10. We're going to convert it into base 10. Can you see that? We're going to convert it into base 10. So the first thing we do is always to start from here and give a 0 here. Count numbers from that side. So this is 0, this is 1, this is 2, this is 3, and this is 4. All right? So that when we do that, because we're already in base 2, this 1 here will be 1. We multiply by the base. And then the base will take this 4 here. Plus, right? This number here is 1. Multiplying by the base that we are in, which is 2. All right? And then the base, the exponent 3 will be here. Remember, we use 4 here because of the number here. And we're going to use 3 here with the number. Now, the next thing here is this the other one here, which is also going to be 1 times the base. All right? 1 times the base to the power 2. Plus, the next number is 0. So that's 0, 0 times the base. And that base, this one, will take 1 here. Plus the last number, which is 1. Okay, last number, which is 1. It's going to be 1 multiplied by the base to the power 0. Like this. And then we try to solve it in a very nice way. Once we get the answer, that answer is going to be in base 10. So always start with, to convert something to base 10, you always write these numbers at the top of the number that you're trying to change. And then once you have that, everything will be fine. Now here, we know that this is going to give us 16. How do we know that? 2 to the power 4 is 2 times 2 times 2 times 2. This is 4. That is 4. And we are multiplying. So 4 times 4 is 16. We have 1 times this. Plus, this is going to give us 1 times 2 cubed, which is 2 times 2 times 2. This is 4 times 2 is 8. Plus, plus 1 times 4. Plus 0 times 2 plus 1 times 1. Now we are going to basically simplify them. This is going to give us 16. All right. Plus this and this is going to give us 8. This and that is going to give us 4. This is also giving us 0. And that is also giving us 1. All right. So that when we add everything, we're going to get this will give us 24 plus 4, 28 plus 1, and it's 29. And that gives us 29, 29 base 10. 29 base 10. 29 base. So that's how we convert something from one base to a base 10. Something from one base from base 10. Please, if you haven't yet subscribed to our channel, please do us a favor by helping us grow this channel together as a family. Yes, and be looking out, turn on the notification bell so that when we post something, you can be able to receive it. And we are going to be looking out for our shorts. We're trying to solve questions in a minute. So anytime we do a video, it doesn't end there. There are questions we will continue to serve you with, so that after watching a video, there are many questions out there for you to help you prepare for where you're supposed to be at. All right, all right. So the next thing we're going to be looking at, we're going to look at how we can be able to convert. Okay, we're going to still continue with the conversion. Remember we're in base 10, trying to go to other bases. So we've done the one that we're in a different base and went to base 10. Now we want to rather do it the other way around. We want to convert base 10 okay. We're going to convert base 10 to other bases. Base 10 to another base. To another base. Sorry about that. All right. To another base. Convert base 10 to another base. So let's say that we have this question here. Let's say that we have 2, 6, 6 base 10. And we are converting this to base 5. We're converting this to base 5. All right. We're converting this to base 5. We're converting this to base 5. All right. So it's still the same thing, right? It's still the same thing. What we're going to do is that we're going to create like a table. We are going to create like a table, all right? We're going to create like a table where you have the number that the number we are working with here, and then we want to work in base what? We want to work in base 5. All right? We want to work, so let's say that we want to work in the base. And then there's a number we are trying to change, right? This number is in base 10. This 266 is already in base 10. We want to convert it to base 5. So the number we're going to have here is going to be 5. There's a base we want to change it to. So what the base we want to change it to comes outside. It's going to do like a long division, like a divisor. And then on this side here, we have a remainder here. All right, nicely. All right. Now, we know that 5 cannot go into 2, so we add this 6 to it, so that it becomes 26. 5 can go into 26. 5 can go into 26. How many times? It's going to be 5 times. Yes, it's going to be 5 times. And that 5 goes into 26 5 times. So that 5 times 5 is 20 what? 25. Then there's a remainder of 1. That 1 will be close to this 6 here. So that 5 can go into this 16 3 times. Why 3? Because 5 times 3 is 15. And 15 from this 16 is remainder what? Is remainder 1. So this is going to be remainder 1, like that. Remainder 1. Then we continue with this 5. This 5 will go into 5 here, 1. All right, and then 5 will go into 3, 0. 5 cannot go into 3, so it's 0. So 5 will go into 53 10 times. 5 will go into 53 10 times. And then there's going to be a remainder, right? There's going to be a remainder. So it's going to it 10 times, and then there'll be a remainder. Because 10 times 5, 10 times 5 is 50, and the remainder is going to be 3. The next thing we're going to do is put another 5 here. We know that 5 can go into 10 2 times. 5 can go into 10 2 times. 5 can go into 10 2 times, and the remainder is 0. Can you see that? There's no remainder. The remainder is 0. Sorry about that. The remainder is 0. Why 0? Because 5 times 2 is 10. So 5 will go into 10 2 times. Because 2 times 5 is 10. And the remainder is what? The remainder becomes 0. The remainder becomes 0. Now we continue. We are not done. Can 5 go into 2? No, it's 0. 5 cannot go into 2, so it's 0. It's not possible. And what is going to be the remainder? The remainder is going to be 2, because if you take 0 from the 2, it's going to be 2. So 5 goes into 2, 0, but there will be a remainder of 2. So that now we can rewrite our number base, right? We can write it. So it's going to be, we start writing this way. All right, so it's going to be 2, 0, 3 is next, and 1 is the last one. And then the base is going to be base 5. It means that 266 base 10 is the same as 2031 base 5. So that's how we convert. That's how we convert any base. So if it's base 7 here, it's going to be 7. If it's base 8 here, it's going to be continue to be base 8 or 9. We keep doing that. And then whatever we get here under the remainder column is how we're going to rewrite that particular base in a different number that we are looking for. Now let's look at how you have a base, like a different base, right? Like a different base, and then you want to also change to another base. So let's say that let me pick this one. Let's say that we've been given this a write 2121 and it's in base 3. They want us to write it as number, write it to a number in base 4. We are writing this number to the number in base 4. That's the goal. We're writing this number to a number in base 4. Now watch that. Notice that we are not in base 10, right? We are not in base 10. So the first thing is to convert this thing. What we can do is to change this to base 10 first. That's what we should do. If you're working between from one base to another different base, not base 10, but another different base, we should change the first base to base 10. Then from the base 10 to the other base. You know how we can convert from base 10 to another base. We've already done that where we did something like a long division, right? But before we do that, we have to work out how we can change a certain base to base 10. And I know you remember that. We said that we write a number 2121 base 3. And we said that we will write something on top here. We start here 0, 1, 2, 3. The moment you start doing that, you want to change it to base 10. We want to change it to base 10. And how do we do that? We take the first number. We said we take the first number, which is 2. We take the first number, which is 2. And the base, what base are we working with? It's 3. And then we put a number 3 here. The next one is the next number here, which is 1. And then the base again, right? The base again, which is 3. And then we put a number that is over there. The next one is 2, which is 2 multiplied by the base to the power 1. The next one is 1. The last number there is 1 multiplied by 3. This 3 here to the base 0, to the exponent of 0, right? Like this. All right. So you can see the basis keeps repeating itself. The number with the base itself keeps repeating, right? And then this is the number. The numbers also appear. And the bases take these numbers. The base 3 takes these numbers. Don't forget that. Please, it's important. Don't forget that. So we're going to have 2 times. This is going to be as 27. How do I know that? 3 to the power 3 is 3 times 3 times 3, which is this gives us 9 times 3, 27. Plus, this gives us 1 times 9. Plus 2 times 3 plus 1 times 1, because any number raised to the power 0 is 1. Don't forget that. And we said we're going to have 54 here. We're going to have 9 here. We're going to have 6 here. We're going to have 1. So 54 plus 9 is 63. 63 plus 6 is 69 plus 1 is 70. And that 70 now becomes a number in base 10. Now, once we are done, we are not done that. We are not done yet. So we're going to still do a long division where we have our 70, which is the number. Okay, we have a 70 with a number, and then the base that we're looking for is going to be the number. And then the base that we are looking for, we want to convert it to base 4. We want to convert it to this. So the base comes here. And then we have a remainder column. Here. So first, 4, we're going to 70 how many times? If you think about it, it's going to be what? First, you can say 4 goes to 7 one time, right? 1 time, but remainder 3, right? 4 going to 7, 1, remainder 3. And then you add 0 to the 3, becomes 30. So that 4 can go into 37 times. 7 times 4 is 28, right? So 28 from 30 is remainder 2. We put that remainder here. 4 will go into 70 how many times? It cannot be 5, but it can be 4. Because 4 times 4 is 16. 16 from 17 It's remainder 1. Can 4 go into 4? Yes, can go. It's 1, 1, 1. Is there any remainders? No, there's no remainder because 4 can go into 4 exactly 1. No remainder. What about 4 going to 1? Is it possible? No, it's not possible. So we put 0 here. 4 cannot go into 1, so it's 0. But there's going to be a remainder, right? 4 can go into 1 0 times, but there'll be a remainder of 1. So that we have been able to convert this 2121 base 3 to base 4, which is going to be starting from the bottom, which is 1 0 1 2 base 4. All right, which is 1 0 1 2 base 4. Base 4. Now the last thing we're going to do so that we can conclude this video is where we have an unknown. Where we have an unknown, we have an unknown equation. We have an unknown equation. Let's say that we are being told to evaluate 365 and it's base 7, right? It's base 7. We are adding to 43 to the base x. We don't know that base. And then we also, and they're saying that all will give us 217 base 10. 217 base 10. So what do you think we're going to do? I think it would be nice if you and I can convert this one first to base 10. And then also, convert this one to base 10. We don't know, but we can do that. So that this one is already in 10. This one is already in 10, so we don't have a problem with this side. But here we don't know. Here too we don't know. So let's first do that. And once we're able to do that, we can be able to evaluate it. So when we have an unknown base, convert each of those bases to base 10 so that it can have a level playing field to deal with. A level playing field to deal with. So let's say we have 3, 6, 5. Here's 0, here's 1, here's 2. That's how we change to base 10. Do you remember that? And we say we take this one, the number first, by the base. What base do we have here? This is base 7, right? So it's going to be base 7, and then exponent is 2. The next one is this number, 6, multiplied by the base, 7, to the power 1, plus the next number. The next number is 5, multiplied by 7. This number is 5, multiplied by the base. We told you the base keeps the same, and then the exponent goes to the top, which is 0, like that. And then we're going to have 3 times 49, because 7 squared is 49, plus 6 times 7, plus 5 times 1. And then we end up getting 3 times 49, 49 plus 49. We have 49 times 3. 3 times 9 is 27, so write 7. We carry this 2. 3 times 4 is 12. 12 plus 2 is 14, like this. All right, so we have 147 here. And then this is giving us 42. And then this is giving us 5. And then when we add everything, we're already in base 10. We're already in base 10. So 5 here plus this 2 is 7. 7 plus 7 is 14. Write the 4 first. Remainder 1. Remainder 1 will be on this one here, which is 5, by this 4, which is 9. And then the last number is 1. And this is in base. 194 is going to be in base 10. And so it means that this number is representing this 365 base 7. We've converted 365 base 7 to 194 base 10. We've done that successfully. We've done that successfully. Now, let's take a look at 43 to the base x, and we want to convert it to base 10. We always said that we are going to have a 0 here and a 1 there, so that we're going to have 4 here multiplied by this base to the power 1, plus 3 times the base to the power 0. Don't forget, it's the base that takes the exponent. The base takes the exponent. The base takes the exponent. Don't forget that. So that here becomes 4 times x to the power 1 is 4x plus 3 times. This is 3 times 1 because x to the power 0 is 1. Any number raised to the power 0 is 1. So 3 times 1 is 3. All right. So that we are having 4x plus 3 is to base 10. All right. And it's all equal to 217. So basically I'm going to continue here, please. We are having 194 base 10. Can you see that? Plus 4x plus 3 base 10. Okay. And it's giving us what? 217, right? Base 10. So we don't know this well. So we can bring this one here. All right. So that we have 194 base 10 minus 217 base 10 is equal to negative, right? It's going to be or we can, since we are looking for the x, okay, let me take it again. Okay, let's take it again. Okay, so everything, you know, let's take it again. Sorry about that. Let's take it again. All right, we already have 194 base 10 plus 4x plus 3, which is also in base 10, is equal to 217 base 10. We want this, so we can keep this one here and have 217 base 10 here. All right, 217 minus 194 base 10. Can you see that? So now we have 4x plus 3 here, and it's in base 10. So we can keep this 4x here equals to 217 base 10 minus 194 base 10. And then this 3 also go there to be minus 3 base 10. You get it? So that we're going to have, we're going to work it somewhere. Let's work it somewhere together. Let's say we have 217 minus 194. So that 4 minus 7 is 3. It's in base 10. Don't forget that. 9 cannot be taken away from 1. So we borrow 1, and that 1 we borrow is 10. We added that 10 to the 1. We get 11. 9 from that 11 is 2. Remember, we borrowed 1 here. So this 2 is now 1. 1 from 1 is 0. So this is 23. Can you see that? This is 23 base 10 minus 3 base 10. 4x. 4x is equal to 20 base 10. Can you see that? And then we divide every side by 4. So that x is going to give us 5 base 10. So the base, that x there is 5. That value of x there, that x there is 5. So for our base for the 43, the base here that we're supposed to have for this 43 is supposed to be 43 base 5. And that's what we have been able to do here. All right, I'm going to end here and come back to you another time with another wonderful video. But please, if you haven't yet subscribed, please do us a favor by helping us grow this channel together. Please subscribe. If you're already a subscriber, I want to thank you for helping us grow this channel together. I'll come to you another time. Take care and bye.